Okay, today we're going to talk about 7-segment displays for use in our digital circuits class. Okay, first off, talking about them, you see we've got one here. This is called a 7-segment display, or sometimes we refer to them as SSDs. They're normally configured into a figure 8 pattern, and each segment is made up of different LEDs. You should recognize this from maybe an alarm clock, the timer on your microwave, VCR, DVD player, any kind of stuff like that that uses digital circuits. If you need to display numbers or information, we typically use 7-segment displays for it. Each segment is an LED, and each segment is labeled either A, B, C, D, E, F, G. And then some of the models also have a decimal point add-on, and they're labeled as just DP. There are two models available. There's common anode and common cathode. And the first configuration is common cathode. You see here, if the common pin on here is a ground pin, so we would hook up our common pin to ground, and then we would send a 5-volt signal, our digital high signal, to A, B, C, D, E, F, or DP for our decimal point, for whichever segment we wanted to light up. The other configuration would be common anode, and it's the exact opposite of common cathode. Our common pin on this one instead is VCC, and we would send a 0 or a digital low signal to our each segment pin in order to light it up. You can make simple numbers of letters with this. You can make any digits 0 through 9, or we can make select alpha characters with it. You see, we can only make A, B, C, D, E, F. Can't make a G, H, I, J. Can't make a K either. L, N, O, P. Can't make an M. We can make an R. We can make an S. We can make a U. Y and Z. Can't make a W though. So this is just an example of a simple message that we can make. So cold soda. Okay. Going back to the common anode, to be on, it would have to be connected to ground. To be off, it would be connected to power, and our common pin is going to be power. Okay. So this is a 7-segment display simulation on Multisim. Right now it's blank because there's nothing on it, but if I connected any of these segments to ground or positive, or if I connect to the positive, they're going to be off. If I connect any of them to ground, it's going to illuminate the segment. Okay. So an example of common anode being used, what value here would be displayed in the common anode segment display shown. Okay. So all we need to do, remember, on the common anode, our segment's going to light up if we connect it to ground. So we've got, in this case, we've got B and C, and then F and G connected to ground. Okay, so go back, B and C, F and G connected. So that would be a line here, F and G, a 4. Okay, so let's see if we were right, and we are. Okay, so we've got 0 volts going to B, C, F, and G, 0 volts on common anode, or off ground, connects it to, and turns it on. We're sending 5 volts to A, D, and E, and remember on common anode, positive high, or 5 volts, turns that segment off. Okay, so B, C, F, and G are the only segments that would be on in this case. Alright, so picking back up with common cathode. Remember, common cathodes, the segments are on when they're connected to power. Segments are off when they're connected to the ground. And our common pin on our display is going to be connected to ground. This is the one that we're primarily going to use in class. Alright, so for this instance right here, all of our segments are connected to 5 volts except for our C segment and our F segment. Okay? So if we go down, what value is going to be displayed? The value displayed would be 2. Okay? Because everything but our C and our F are connected to positive 5 volts, and that means it's turned on. Okay, so we're sending 5 volts to A, B, D, E, and G, and if you look at your diagram, that's going to illuminate what looks to be a 2. Okay, that's about how to do common cathode and common anode 7-segment displays.